Hi, everyone! Welcome to the fourth episode of the video series about evolution from traditional VPN to EVPN. This episode focuses on how to smoothly evolve from L3VPN over MPLS to EVPN L3VPN over SRv6. It will help you better understand the evolution process in terms of the networking plan, evolution procedure, and rollback method so that you can improve network evolution efficiency. Before the evolution, MPLS tunnels are used to carry L3VPN services. BGP VPN v4 peer relationships are established between PEs, including P1, P2, P3, and AP that serves as the RR. The RR reflects BGP VPN v4 routes among PEs. After the evolution, it is expected that SRv6 tunnels be used to carry EVPN L3VPN private line services. BGP VPN peer relationships be established between PEs, including P1, P2, P3, and the RR, and BGP VPN routes be reflected by the RR. Here is the overall evolution roadmap. First, configure SRv6 tunnels, SRv6, and BGP EVPN peer relationships. Second, configure an EVPN L3VPN instance. EVPN L3VPN and MPLS L3VPN share the same VPN instance. Third, configure EVPN routes to be preferentially selected. Fourth, as an optional step, roll back services from EVPN L3VPN over SRv6 to L3VPN over MPLS. Fifth, after all services evolve to EVPN, delete L3VPN over MPLS and other redundant service configurations. Now, let's take a look at the detailed evolution procedure. The NetEngine 8000 is used as an example to demonstrate key steps. First, configure SRv6 BE tunnels on PEs and the RR. We will use PE1 as an example to describe how to configure the source address for SRv6 encapsulation. It is recommended to use a loopback interface IPv6 address as the source address. Configure an SRv6 locator, which specifies the length of the static SID segment. Dynamic SIDs are allocated outside the static SID segment range to avoid SID conflicts. The configurations of P2, P3, and the RR are similar to that of P1, and so are omitted here. Next, let's configure IPv6. Here, P1 is used as an example. Configure local microloop avoidance, IPv6 topology-based independent IPv6 route calculation, BFD for IPv6 peer, is SRv6, and SRv6 microloop avoidance for traffic switchback scenarios. On each involved interface, enable IPv6 forwarding, configure an IPv6 address, and enable ISV6. The configurations of P2, P3, and the RR are similar to that of P1, and so are omitted here. Next, let's check the ISV6 configuration. Here, P1 is used as an example. Run the display as peer command to check whether is neighbor relationships have been successfully set up. In the command output, if state is up and system ID is asterisk, P1 has successfully established ISV6 neighbor relationships. Run the display as root command to check root information, including the outbound interface, next hop address, and link cost on P1. The command output shows that P1 has learned loopback routes, locator routes, and interface network segment routes from P2, P3, and the RR. Next, let's configure BGP EVPN peer relationships between each of P1, P2, and P3 and the RR. The RR establishes BGP EVPN connections with PEs to reflect BGP EVPN routes. The following uses P1 and the RR as an example to describe how to configure BGP EVPN peers. The configurations of P2 and P3 are similar to that of P1, and so are omitted here. Next, let's check the BGP EVPN configuration. Here, we will take the command output on P1 and the RR as an example. Run the display BGP EVPN peer command on P1. The command output shows that a BGP EVPN peer relationship has been established between P1 and the RR, and state is established. Run the display BGP EVPN peer command on the RR to check whether BGP EVPN peer relationships have been established. The command output shows that the RR has established BGP EVPN peer relationships with P1, P2, and P3. Run the display BGP VPN v4 all routing table command on P1 to check routes destined for the enterprise site connected to P2 and P3. The command output shows that P1 has not received any EVPN L3VPN over SRv6 route, and the current service is still L3VPN over MPLS. Step 2. Configure EVPN L3VPN. We need to configure EVPN VPN targets, and then enable EVPN to advertise IP prefix routes, configure VPN routes to carry SIDs, and configure route recursion based on SIDs in the EVPN address family. Here, P1 is used as an example to describe how to configure EVPN L3VPN. The configurations of P2 and P3 are similar to that of P1, and so are omitted here. In this case, because the BGP VPN address family preferentially selects routes with IPv4 next hops by default, L3VPN services still need to recurse to MPLS tunnels. Run the display BGP VPN v4 all routing table command on P1 to check specific BGP routes destined for the remote enterprise site. Now, the device has EVPN L3VPN over SRv6 routes that can recurse to SRv6 BE tunnels, but these routes are not preferentially selected. Step 3. Configure EVPN routes to be preferentially selected. On P1, configure the VPN instance to preferentially select routes with IPv6 next hops. Next, let's check whether EVPN routes are preferentially selected on P1. Run the display BGP VPN v4 all routing table command on P1 to check specific BGP routes to the remote enterprise address. The command output shows that the BGP VPN instance named VPN1 has preferentially selected EVPN L3VPN over SRv6 routes on P1. Run the display IP routing table VPN instance command to check the IPVPN routing table. The command output shows that routes have recursed to SRv6B tunnels based on next hops. At this time, P2 and P3 have not been configured to preferentially select EVPN routes yet. Run the display BGP VPN v4 all routing table command on P2 to check specific loopback routes on P1. The command output shows that the BGP VPN instance named VPN1 still preferentially selects L3VPN over MPLS routes on P2. This is an intermediate state during the evolution from L3VPN over MPLS to EVPN L3VPN over SRv6, during which PEs at both ends may use different transport solutions. That is, traffic from P1 to P2 and P3 has switched to SRv6, but traffic from P2 and P3 to P1 is still carried over MPLS. On P2 and P3, configure VPN instances to preferentially select routes with IPv6 next hops. On P2 and P3, check whether EVPN routes are preferentially selected. Run the display BGP VPN v4 all routing table command on P2 to check specific loopback routes on P1. The command output shows that the BGP VPN instance named VPN1 has preferentially selected EVPN L3VPN over SRv6 routes on P2. Run the display BGP VPN v4 all routing table command on P3 to check specific loopback routes on P1. The the command output shows that the BGP VPN instance named VPN1 has preferentially selected EVPN L3VPN over SRv6 routes on P3. At this point, bidirectional traffic between P1 and P2 and between P1 and P3 is carried over SRv6 tunnels. Step 4. As an optional step, rollback services from EVPN L3VPN over SRv6 to L3VPN over MPLS. If services are not as expected after the evolution, run the following commands to roll back them from EVPN L3VPN over SRv6 to L3VPN over MPLS. Commands must be run in the following sequence. Here, P1 is used as an example. Enter the VPN instance view and delete the EVPN VPN targets from the VPN instance. Enter the BGP VPN instance view and disable the VPN instance from preferentially selecting routes with IPv6 next hops. Disable EVPN from advertising IP prefix routes. Disable the BGP VPN instance from adding SIDs to routes to be advertised. Disable the BGP VPN instance from recursing routes to SRv6 tunnels. The rollback procedures for P2 and P3 are similar to that for P1, and so are omitted here. Let's look at the rollback result. On P1, check the routes destined for the enterprise site connected to P2 and P3. The command output shows that the EVPN routes have been withdrawn, and the current service is still L3VPN over MPLS. After all services evolve to EVPN, delete L3VPN over MPLS and other redundant service configurations. First, delete the VPN targets of the L3VPN instance. Then, delete the preferential route selection configuration of the BGP VPN instance. After L3VPN over MPLS evolves to EVPN L3VPN over SRv6, delete BGP VPN v4 peer configurations. Deleting BGP peer configurations is a high-risk operation and will cause peer relationships to go down. You are advised to perform this operation in the cutover window. The configurations of P2, P3, and the RR are similar to that of P1, and so are omitted here. Check specific BGP routes destined for the remote enterprise address on P1. The command output shows that P1 has received BGP VPN routes from P2. Run the ping VPN instance command to test the connectivity between P1 and the remote enterprise address. The command output shows that the connectivity is normal and no packets are lost. Now, the evolution from L3VPN over MPLS to EVPN L3VPN over SRv6 is complete, and all service traffic is switched from L3VPN over MPLS to EVPN L3VPN over SRv6. That's all for this video on the evolution from L3VPN over MPLS to EVPN L3VPN over SRv6. Thank you for watching.